Okay, we've got GPIO and we've got core. And under core, we have our include and our source. And we also have something called under startup. And we looked at some of these different files last day. If we double click and we look at startup, it says startup has what's known as the device's vector table, initial stack pointer, initial program counter, and after reset, here we'll go, and it runs all of this stuff before it goes to main. So this is defining, let me just, incidentally, if I double click on one of these things, it goes at full screen. And then if I double click your application, it goes back to where you originally wanted it. If you close some of these menus or accidentally close a table, you can always go to Windows Perspective and reset perspective, and it puts it back to the way you began. Okay, so I've often gone, oh, I shut down something and I wanted that back and stuff. Just go into your perspective and reset perspective. The perspectives are, for instance, if you look up here, I've got a C, C++. That's your when you're editing it, the device configuration tool perspective, the debug perspective. And you'll notice when you go and open things, it says there's a little box that comes up and says, hey, when you're in the debug perspective or in the C++ perspective, do you want me to open up the window configuration you've set for that? And there's a little checkbox that says, do you want me to always do that so I don't keep asking you? So you just check it, because when you're going to edit, you generally want however you've got it configured for editing. When you're debugging, you generally want to do all of that kind of thing. So it's a good thing to just say, yeah, just always do it. And again, if I mess something up, I can go window perspective, reset perspective, and it will do that. And so in our startup, it has defines for where the reset is when you first boot up. It's got some ARM actually assembly language going here, and it does things like if you're initializing something, fill certain sections with zeros. Here's the machine language for going to main. That's how it starts up main when you go and run. Some of the other things that are in there, and we'll look at it a little bit more coming up, it's got something known as a vector table. And there's the vector table. Okay, and basically it's got all of the names for the interrupt service procedures. In the PIC world, you're used to, if you have an interrupt, you go to a certain address. And in fact, some of the later PICs, you could have a high priority and a low priority interrupt, and you could go to two different places. Well, the way ARM works is very similar to the way the PC works, and there's vector tables. And so you set up where your interrupt service procedure is for all the different things that are going to be triggered, timers or A to Ds or what have you. And then there is something known as a nested vector interrupt controller, which goes and you in software configure the priorities of all your different interrupts. And then depending on the priority list, the nested vector interrupt controller tells the ARM, go deal with this. So it can have up to 240 external interrupts, and then you set the priorities, and then it just tells the ARM when an interrupt happens, or if multiple ones happen, this is the one you deal with right now. And what it does is it gives it the vector table number, and it goes and looks up where the interrupt service procedure is. Okay, and we'll talk more about that next time. But this is where you find it, in that startup. And then there are a bunch of defines for them, and they're defined as weak. And I don't know if you've seen that before, but predefined names for the interrupt service procedures, you may not use them, and it doesn't want to have, hey, you've defined something but didn't use it, and so it's defined as weak, so you can override it. It's just a placeholder, okay? So if I came up with an interrupt service procedure for something and it was already defined with this .weak, it won't give you, hey, you've got two defined. It goes, you overrode that one, all right? I'll come back to this. It's just so you know where it is. And as soon as we start talking about interrupts. And then, so I've got my main. If it opens. Okay, and again, I tried to make it so it was a bigger font. And so we have our main.c, and we had all our program in there. And one of the things that we looked at last time was, okay, the graphical environment goes and initializes a bunch of things for us. So for instance, the clocks are all there. So system clock config, everything you did in that clock menu happens here. When you are doing your, where is it? My GPIOs. And so the GPIOs, it says the graphical environment says you were playing with LEDs and maybe your buttons and what have you. So it initializes them for what you said. I want my LEDs to be outputs. I want my button to be inputs. So it sets all of that kind of stuff up for you. Now, we looked last day under the week 2 GPIO structure about how it does some of that. And for instance, there is a __ HAL RCC, which says GPIOD clock enabled. So it's turning on the clocks. Remember, there was that picture and it had the arm in there, and then there were a bunch of buses, and it goes down to the ports. So it goes and enables everything along the pathway to be able to make that happen. And that was a common source of errors before it automatically did all of that. Was you had to get that picture out and follow it and make sure you turned everything on along the way. And it just does it. It also nicely comments it, and it says, hey, we're going to start off with all your output levels to be low. Now you can change that in the graphical environment. When I go to GPIO, I can say, no, start this one off high, start this one off low. You can do all of that kind of thing. We just have left it all at its defaults. Okay. Then it went and said configure button pin. So that, of course, was our input. So it says GPIO init struct.pin. Let me just go up just a little bit here and have a look. If I can, come on. That structure, GPIO init type def, okay, so that's a structure, and there's an instance of it called GPIO init struct, okay? And so I'm going to use that to go and configure everything. And again, if I highlighted over this, it should, okay, you should be able to just hover over it and have it pop up and show you what's in it. Or you can right click and go open declaration, and it'll open the header file that it's in, and it will go there, okay, if you want to look at it. But just highlighting it usually, and it'll show you this. You can hit F2 and then scroll through it, for instance. But that's showing you all the things we talked about last day, which was, you know, pin and mode and pull and all of that. And so GPIO init struct.pin, well, what pin do you want to work on? And we looked at each one of those things, whether it's pin 1 or pin 15 or pin 0 or pin 15 on a port, it would have just the appropriate bit set to a 1. And we ORed all of them together to say, I want to work on all of those pins on a port. Okay. And so I just want to deal with that one pin, and that was on, can't remember, PA0, right? PA0. So they're in, it says button pin. Where would I find that it's PA0 if you went looking, other than opening up the graphical interface? Where do you find where it says PA0? Well, yeah, data sheet. If in a code, where do I find it? Yeah, main.h goes and it links all your stuff with the actual ports. And the reason I mention that is because if you add another file sometime and you're using some of the stuff that you defined in the graphical environment, they make the associations between your names and where they are in main.h. So if I said in another file, oh, I want to deal with a button pin here, it doesn't know what that is unless you include main.h. Okay, so that's where those associations are. And then GPIO init struct mode equals input. Well, that's of course what I want. And no pull-ups or pull-downs. And then HAL GPIO init is that initialization function. And it says, hey, the button port, which is port A, I think you said, and then the address of wherever this instance of that structure is. And then that function goes through, looks at what pins you want to do stuff with, and then goes and does all the other stuff with it, sets the 1s and 0s. And we looked at that they were 32-bit registers. and there's a base address. So port A, B, C, there's a base address, and it starts off with mode, and then it's got speed, and then well, input outputs, and all of that kind of stuff. And each register that's dealing with a specific port is the same offset along. So when I pass it in the base address of port A, B, C, D, it knows to then go to the GPIOA or what have you, and then do things with it. And it knows how to set up mode because it's right at the start, and then the next thing's 4 bytes after, and the next thing's 4 bytes after. And so that's how it figures out where all that stuff is. Okay, doing the same thing, I say GPIO pins, green, lead, orange, red, we want those all to be outputs, and there's multiple ones we want to do at the same time. And this GPIO init will go and look at, I've ORed all of them together, and those, each one is, 0, 0, 0, well, actually it's on pins 15, 14, 13, 12, so when I OR them all together, I'll have 1, 1, 1, 1, and then 12 zeros, okay? And so this function goes and looks to see what bit position to do something on, and then goes and sets all the bits. So I want to work on 4 pins here, and I want them all to be outputs and push-pull. That's the standard. No pull-ups or pull-downs. And the frequency is low because it's LEDs, and I'm not going to see it going really fast anyway. Okay, and then we call HAL GPIO init, and I pass it in D. This time I pass it in A there. This is saying D because I defined a green, orange, red, blue, and so it has a definition in main.h, green, green lead port, blue lead port, red lead port, but we're dealing with all of them, and it doesn't know what one it should call it. So it just calls it port D, okay? In here, we only had one, and it was all named the same thing, so then it was able to just say, well, that's the name of your port. So that's what we have there. And again, we went into that more specifically last day to say, hey, this is when you see a bunch of code generated, then it's like, oh my gosh, it's overwhelming. But it's just going through and saving you from having to look up the registers, set the right things. And quite often they would find that you would miss something. There's so many registers, there's so many options. So they say, here's a base configuration. You told me you wanted outputs, or you told me you wanted inputs. There it is. Doesn't know what you want to do with it. Same with when we go to A to Ds. Next week, we're going to start to look at analog to digital converters. We just say, okay, I want to set up this pin as an A to D. It configures all of that and lots more registers. Here it is. Don't know what you want to do with it, but it will work if you give it the right sequence of things. And in the HAL, it will tell you what you have to do. And in fact, in the HAL manual, that 1,800-page API, it says to configure GPIO, you have to do all of this kind of stuff, and it's a whole ton of things. Well, they did that for you. And then it says to use it, here's the things that you have to do. Use HAL GPIO write, HAL GPIO read, HAL toggle, and I can do all that stuff. I know it set up the rest of the stuff for me. Okay, and so there we have all of that. Now I want to then, oops, there we go, go back to there. And I want to go on GPIO, and then we are going to go debug. Oops, should plug it in. If you don't plug it in, it says no ST-Link detected. That's telling you you can find an ST-Link because you didn't plug it in. Hopefully, if it is plugged in, there's some sort of other issue. You should see the bottom light kind of flashing a whole bunch saying the data is moving back and forth. You know, that little one right there, it'll flash multicolored. Downloaded to it. And by default, the way the debugger's set up, they've done a few things for you. And one of the things they say is go to the first line of code. So it stops at the first line of code. And so there's my arrow. We're HAL init. And so up here, I have a step into, a step over, a step out of, and we'll go into instruction stepping mode. This one is my step return, which means if I got into a function and then I'm happy and I want to get out of that and go back to the upper level, whatever called it, then that's the step out. And then we also have this resume, and then there's a terminate, and there's a terminate and relaunch. Sometimes I look at that. That's what, if I just want to run it, you just hit that. Okay. If you do that, this one is run. And what that one does is it programs and it runs it so you're not having to debug and step through the thing. So you can do that kind of thing. So I want to just step through. So HAL init is the hardware abstraction, and it said, hey, if you're going to do any HAL APIs, you got to initialize the HAL API first. And so you call HAL init. And so what I want to do is I want to click on this, step over, and so it jumps down to the next line of code. System clock config. We saw that. That's below our while one, and it sets up all the clocks. And I don't want to have to step through that. I could by just going step into, but I'm just going to step over, which means execute it and step over, then initialize the GPIOs. And so I could step into that. Let's step into that. And so that should take me into where that function is. And there it is here. And so we could then step over. And when I step over one, and it's enabling the clocks for H, A, and D. And then it says HAL GPIO right green LED, red LED, and that's putting them all to low. So we could do that. And then I go, you know what? I shouldn't have got in here. And so I want to go step return to get back out of there and finish executing it, get back out of there, and go to the next thing. The random number generator initialization, if you enable it, RNG in your graphical interface, it lets you do those last little clocks down below there that it may not have let you set up, and it's okay if you didn't. We're not using them right now. And then so I'll go step over, and then it says int count equals 0. And hey, there's a count over here that's it's saying 0, so we'll go there. And then it says read pin. Okay, and so I'm so it says, let me just double click this one. Okay. Okay, what's that? Yeah, you seen the ternary C operator? Bill talked to you about that one. It's kind of a lazy if then else statement, or if else statement. So if you look above, okay, let's go just above. Okay, so this one says if HAL GPIO read pin button port button pin, so it's going to read it, it's going to return. It's an enumerated type of GPIO pin set or reset, which means it's a 1 or a 0. If you go and look at HAL GPIO read pin, it says it returns a set, a GPIO pin set or reset, which is, again, 0 or 1. And then it will run my clockwise function. Otherwise, it will run my counterclockwise function. Okay, and then somewhere down below in user-defined for, I have clockwise and counterclockwise. And so it's always going to run that. Well, that's a frequent thing where you say, if this, do one thing or another. So what you can do is use what's called a ternary operator in C. And so I have HAL GPIO read pin, just like before, but instead of terminating it with a semicolon, I've got a question mark. And so you say, read this, and then you go, is it true or not? Okay, and so it will run one or the other. So it's just a shorthand form for that. So instead of HAL GPIO read pin, I could have X less than 5, yes, no. Okay, so question mark, and then you have a colon between the two, and then you terminate it at the end. Okay, this is exactly the same as that. Yep. It's always yes, no. It's always yes, no. Okay, and so then we go count plus plus. So let's continue on. So I've done that. And let me just shrink that down. And then let's go step over. Okay, and then so count plus plus, and then we step over, and it shows it goes kind of pink, saying it changed from the last thing you just did. It tries, if you had a whole ton of variables and stuff, it would try to do that, and then it goes our count mod equals 4. Okay, and read pin, and then go somewhere. So if I step into, then it should decide to go in to one of these. So if I go step into, then it will take me down to whether it's going to set or reset this. Let me go step return, see if it'll take over there. That's some of the built-in stuff that it's got. Okay. Now, the count plus plus, you see all of this, and it says it's GPIO pin reset. If actually I could do this, if I hold down the button, and let's step over again, or step over, should be able to tell me. Let me go in. We'll go step return, and then it shows pin set. Now, one of the things about over on the right-hand side here is it's going to be whatever's currently in scope. And so if I go to another function, was in main is no longer in scope. Okay, so it doesn't know how to track that. And so if I put you can up here, and I'll show you some of the ways, I can put a whole bunch of variables there, and they'll go out of scope every time you jump into a function, or if it was in a function, every time you're out of the function, it says out of scope, because for instance, normally when you leave a function, all the variables are destroyed unless you do static, for instance. And so one of the things in order to do some debugging is, don't tell Phil, but we put some globals. Now you don't normally want to put globals, but if I want to track a variable using the debugging features so it doesn't go in and out of scope, then you would put something global. After, you can get rid of that, when you find out what's going on. But if there's something you want to track, you put it as a global. Okay, and so and one of the things is some of the debugging will happen. There's some extra silicone on the ARM chip, and it has a pathway to route some of your variables out without using printfs and all of that kind of stuff. And you can display them on other consoles and things. And so you can monitor what's going on. Well, it can grab your variables whenever it wants to. And so if you have a variable that is changing, because let's say every time through a loop or something, I'm adding something to it, and then at the very end, I divide by 16 or something like that, you can see a nice value, and then all of a sudden it drops by 16 every once in a while, because it depends on when it grabbed it. Okay, and so we'll talk more about that as it comes along, but you have to say, be careful about what you're asking for, because it will just tell you when it sees what the variable is doing as it's running the code. It'll say, I saw this, I saw this, I saw this, which, like I say, if you're doing lots of stuff to a single variable, it could change over time, and it might throw you off a little bit. Okay, the part of this is we're stepping through our code, and so I'm stepping over. Yep. Where did you initialize the count? Let's go to there. Yeah, you always want to initialize stuff. So right there, and so there is my main, and there's Halonet, all the rest, and just after it set everything up, I said int count equals 0. Now, if I have jump into another function, count will go out of scope, okay, because it's not above main, it's local to main, okay, and so that's looking at where things, if it was above main, it's global to everything. All right, so let me just hit this, and I'm going to go Control slash, and we'll do Control slash. I'm going to just stop because I've made some changes. I'm going to go File, and then we'll go Debug again. And this is, if you, for instance, are not sure that you're reading the button or things are working right, it's good to be able to go and, let me just, okay. So let me go back through this. Why isn't it there? Let me do it again. Okay. I don't know why that went there. Okay, so I've got step over. So Helinet, that's annoying as anything. Why it's putting it there? Okay, and so we go gpinit, random int count equals 0. We see count is 0. It says if hal gpio read button, port pin. And so right now, if I go step over, it goes to counterclockwise. If I go step into, I go into the counterclockwise. Again, I don't know why it's all of a sudden putting me over there. It's okay. And so if I say HAL GPIO blue pin set, so when I go there, hopefully it sets the blue pin, and then we go delay, and then it resets the blue pin, and then we go delay. We've got our break, so it goes down to the end, and then it should go back to reading our button again. And so this time, if I read the button and I hold the button down, and then I do that, then it should say, okay, we're going into clockwise. And again, if I just uh, go step over, it'll run the whole clockwise function, come back. Okay, so if I go step into, then it's going to go into the clockwise function, for instance, and then I've got it there. Okay, so I'm all happy with that. So then I can just go resume, and it should just be rotating it around. One of the other things I can do is say, you know what, something isn't working quite right here. So I could put a breakpoint. Should be able to put a breakpoint here if it lets me. Terminate. I think it's having problems with me being zoomed in on this whole thing. There we go. There. Well, actually, I'll do that. Get rid of that. Put it on. I should put it on an instruction. So let's go HAL GPIO right. And then so I'm going to go once again debug. Okay, and I'm just going to go run. And so it's rotating around. And if I hit the button, then it stops at wherever my debug point was. Okay, so I can say something's not working when I hit the button, or when the count is 5 and I hit the button, or I send serial data to it. You can set a breakpoint and say stop whenever you get to that point. And now I can look around. I can view some of my variables and see what's going on there, and say, okay, what's going on here. All I had here is my just this state that was passed in, and it's at value 0 because I was on step 0 on my count, and that's local there. So when I go back out, it doesn't. I passed count into state over here. Okay, I have you often as well. For instance, I have clockwise and I called state. In the main, get back up there. In main, okay, I have a count. I call clockwise and counterclockwise. I pass count. Okay, that's to local to my main. And in my clockwise and counterclockwise, I have state. I have a different name. When you have, if I had count and I called them count in clockwise and counterclockwise, and this was defined in main, it's a different count. It's local to clockwise and local to counterclockwise. It's not the same count as in main. So anytime, hopefully, Phil was having you do functions, or Wayne, you have a different name in your functions. You can have the same name, but it can lead to confusion that you think it's the variable. It is not, because it's different in your function than outside your function. Okay, so I always like a different name to tell you it's different. Okay, so if I have clockwise count, so I am passing the value that I initialized that up here, int count equals 0. So local to main is this integer called count. I set it to 0. I am passing the value of count, whatever that is, 0, 1, 2, 3. I'm passing that over to clockwise and counterclockwise. When you go into a clockwise and counterclockwise, I could have called this int count. I called it int state to tell you it was different. If I say int count, it's not the same count that was above. And so if I do something to count here, it will change local to that function. And when I leave every variable, everything is destroyed in clockwise. And when it goes back up, it's whatever that other count was. Okay, and so that can lead to hard to find bugs because you go, I don't get it. I added 1 to my count in my clockwise and it's not adding up. Now that's different from global. If it's above main, it is seen across all functions, which can lead to problems in itself, and why normally we don't have you do that. Where I will allow you to do that is when we are going to use some of these other debugging features so that uh, it's called a trace macro cell unit, which can look at variables that you want to track. So those ones we will put global so that it doesn't go out of state. Okay. So I've will put a posting of just this if you want to go through some of that. We have a lot more debugging stuff to talk about in the week 2 documentation. I'll start talking about a little bit more setting up clocks and debug. I want to be able to use a print. And so just like you did something special with the Arduino to make floats work with printf. Well, we're going to, the default for a lot of systems is they make a print function, and when it finally goes over to actually putting a character out, they don't do anything with it. They leave it up to you. And so we can redirect printf to print out a serial port, a USB port, or what have you. We're going to redirect it to print out that trace macro cell unit I told you about, and so we can send characters to a debug console. So we're going to look at doing that. It's in this kind of document. We'll talk more about it on Monday. Thank you. Sorry it didn't work at the start here.